person. Okay, hopefully that all made some sense. So in terms of perception, the focus here is sort of on visual perception. With this new study design, they've kind of brought in a bit on taste as well, but like it's mainly still a lot of visual stuff. But just be aware again, when you're using practice questions from earlier years, you might not see as much stuff on, oh my gosh, sorry, taste. Okay, so learning about attention. So this idea of what attention is, the focused concentration towards certain stimuli at the expense of others. So right now, I'm focusing on my laptop and making the presentation, and I'm sort of ignoring, like my heater going on in the background. I'm ignoring any noise from outside the room, that sort of thing. And that's just what attention is. When you focus on something, your brain is always clocking everything that's going on in the room, but you're not always thinking like, oh my gosh, I can hear blah, blah, blah in the other room, and I can see this and I can see that, because your brain is able to kind of hone in and focus on one thing. So sustained attention is just that, when it's sustained, when you're able to focus on one thing over a long period of time. Divided and selective attention are kind of your little opposite. So divided attention is when you are able to like multitask or kind of do two things at the same time. So maybe if you are like talking and walking, or like talking and driving, for example. So divided attention, you can see that sometimes is a bit dodgy, as in like you can't really split your attention perfectly between two things, which is why you can't use your phone while you're driving. But yeah, that's the idea of divided attention, when you've got multiple things in front of you that you are focusing on equally. Okay, and usually they're both sort of simple tasks as well. Selective attention. So selective attention is just when you're focused on one thing and you're ignoring everything else. So like if you're doing a test, for example, if you're doing an exam, that's something where you'd be really putting quite a lot of attention and focus into one thing and ignoring other stimuli around you. Okay, so in terms of this perception, whether it's visual, whether it's taste, whether it's any other form of perception, we have this sort of system from reception to interpretation. So reception is when basically your sensory receptors just get this information in sort of its like raw form. Transduction is when this is sort of converted into a form of information that your body can kind of understand. So if you receive information, let's say it's like maybe like touch on your finger or something, like, or the way I'm touching my table right now, something like that. The reception is this idea of the touch receptors in my finger sort of being activated and realizing, okay, I'm pushing against something here. And then that information gets transduced into something that the body can kind of understand. So perhaps it's sort of like neurons firing, that idea. And then it's transmitted. So this information is transmitted and sent to my brain. Selection is this idea of your brain, as I mentioned, gets a lot of sensory information. It picks up on everything, but we don't pay attention to everything that, our brain is sort of sensing or receiving. Otherwise, our brains would literally explode. So this idea of selection is paying attention to stimuli that is relevant. So like, right now, if my hands are up here, my elbows resting on my armrest or chair. But the whole time I'm giving this lecture, I'm not thinking like, oh my gosh, okay, my elbows are on the chair, my elbows are on the chair, because of this idea that I'm paying attention to this, what's kind of coming up on my screen. So it's that idea that you're paying attention to things that are important or relevant, and other stuff that, your brain is still receiving this information, but it's just not really that important. And then you organize that and interpret it. So I'm looking at this diagram right now. I'm seeing reception, transduction, transmission. My brain is organizing this information and interpreting it so that I'm able to deliver a lecture on it. That's that sort of idea. And again, this happens for touch, this happens for taste, this happens for vision, all of your sort of senses there. And then that's that idea of perception, how you perceive something, and then how you can respond to it as well. Okay, so this idea of processing information. So you've got top-down and bottom-up processing. So your top-down processing, this is when we're actually getting information and we're perceiving it. So I think, you think about top down, it's coming sort of from the brain, whereas bottom up is like coming from your senses. It's that idea. So top down processing is that idea that you've got this information that's coming in and it's dependent on previous knowledge or experiences that you have. So maybe, okay, let me think. If I'm processing something, so I'm going to the beach and I'm getting this visual information, maybe, and my brain is interpreting it and it's using my previous images of beaches, my notion of what a beach is in my head, that stuff, like all my previous conceptions and experiences and expectations of what this beach should look like, what it would look like, blah, blah, blah. And that's that idea of top-down processing. And then I'm perceiving this picture as a beach. And I'm perceiving, oh my gosh, this is the bluest beach I've ever seen. This is the most lovely beach I've ever seen. This is the ugliest beach I've ever seen. That sort of thing. Bottom-up processing is literally just the information. So it's just, there is blue sea coming into my eyes, or the weather is warm. That's it. It's not, oh, I love this warm weather, actually perceiving this thing. It's just my, temperature receptors on my skin are being activated. So that's why it's objective. So it's just literally just the information that's given to you, whereas subjective is how you sort of interpret and perceive something. So hopefully that makes sense. Top down, just think about your brain is really involved. Bottom up is literally just, this is what is coming into my brain. Okay, so we think about the biological influences for vision and taste. This is specifically for your vision. So your physiological makeup, so the actual sort of physiological structure of your eye, the aging, how old you are affects how good your vision is. Obviously, when you get older, your vision gets worse. And your genetics. So again, this genetics and physiological makeup are kind of linked a little bit, but, inherited factors such as color blindness or, astigmatism or something like that, other things that affect the vision in your eye. You can see how all of these biological influences have a big impact on how you are to perceive something. The whole idea with this sort of chapter or area of study on perception is that people can get the exact same input but perceived in different ways. So again, I can be looking at this beach. Someone who is younger than me will perceive it differently. Someone who's older than me will perceive it differently. Someone who's colorblind will perceive it differently. Someone who's got a different shaped eye will perceive it differently. Someone who's lived 30 years overseas will, perceive it differently. It's all this idea about how our experiences and how our, brains and physicality and everything like that influences how you perceive the world around you, basically. Okay, so in terms of this idea of interpreting and organizing information, so you've got your visual constancies and you've got your Gestalt principles. And it's this idea about how things can look different, but you can interpret them and understand them as sort of like not being the same when we think about visual constancies, but then sort of being understandable in terms of your Gestalt principles. So your visual constancies, when we think about size, it's this idea of things that are closer to you will look bigger and things that you push further away will be smaller, but you understand that they are the same size. So, for example, like this humongous giant cup that I'm holding, when it's closer to my face, I can understand, it's a big cup. When I push it away, it looks smaller, right? But I know that this cup hasn't just shrunk in size as I've pushed it away. It's this idea that, I can tell, like based on depth and stuff like that, that this is a constant. It doesn't change change size. Shape is the same thing. This idea of from one angle, my laptop may look different. From this angle, it may look different. I know that my laptop isn't shape shifting. It's this idea of I'm moving my eyeballs, basically. And then same thing with brightness. So your brightness can sort of change. In the laptop probably isn't the best example because it emits light. But like if I'm looking at a picture frame on the wall, in the morning with full daylight, it'll be light. In the evening, it'll be a little bit darker. I know that this paper hasn't changed color. It's that It's simply just the brightness of the room has changed. So that's why we call them visual constancies. These will change, but you understand in actuality that the size or the shape or the brightness of something hasn't actually changed, even though visually it has. Okay, looking at Gestalt principles, we have a nice example of pictures here. Figure ground organization is basically this idea of separating things into what's in the sort of foreground and what's in the background. And that's how you're able to interpret information visually. Proximity is this idea of grouping things that are closer together. Similarity is grouping things that look close or look alike. And closure is this idea of when things have gaps, you being able to mentally fill them in. So with figure ground organization, this is sort of a picture that we're thinking of. So you can see that if you think of the blue as being sort of the figure and the white as the background, this looks like a cup or a chalice or something like that. Whereas if you think of the white as the figure and the blue as the background, it looks like two faces, like two people kissing almost, like facing each other. So that's that idea of figure ground organization. Yeah, you can kind of think about it like maybe this as well, like it looks like a face, but it's that idea of what's in the foreground and what's in the background based on how you're interpreting it. The other ones were proximity. So looking at kind of like this here, you can make out that it's a cube because, this might almost, could almost be closure as well, but this idea of proximity is that you group things that are similar, not similar, like that are closer together, and then you can perceive a picture like that. Maybe like this as well, kind of like this idea that these are closer together, and then you can perceive this sort of a smiley face. That's the idea of proximity. In terms of similarity, so this is this sort of idea of similarity. You group things that are the same color together. So in this, rather than seeing 6 by 6, rather than seeing 36 dots just there, in my head, I see 3 blue lines and 3 white lines. That's the idea of grouping things. Proximity, yeah, maybe this, I don't know. But yeah, proximity is just based on how close things are together. And then lastly, closure. So closure, yeah, I guess maybe like this one. This is probably a good example of closure. You can see that there are gaps, but you know that this is meant to form a tree. This is also this idea kind of closure as well. Like there are gaps here, but you understand that we're forming sort of triangles, even though it's just like 3/4 circles and random little lines here. You can sort of make out this picture of a triangle in the middle, and kind of here as well. There's no line depicting this circle, but you can kind of imagine that. So hopefully that makes sense. There are other really good examples to have a look at, but it's just these principles that sort of allow us to perceive something. It just allows us to kind of make sense of things in our head. So when we see this, we can just see the chalice, so we can see the 2 people. Or when we see this, we can just see, 3 white lines and 3 blue lines. It's just that idea of our brain always wanting to kind of group things, together. Okay, so perceptual set, this basically influences how you perceive things as well. It's just how all of these factors come together to influence how you perceive something. So sure, we perceive something as information right in front of us, but our perceptual set also affects how we interpret that information. So our past experience, the context of, where we're seeing this thing, the emotional state, so again, the sort of affect, and your motivation. So this idea of your sort of, it's kind of weird, but like your feelings to interpret something, or, you can kind of link it to emotional state, but this idea of a reason to interpret something almost. But you can see how all of these 4 things would really influence how you perceive something. And again, this is why 2 people can look at the same picture, but then they can see them in a different way. So maybe, based on past experience, I don't know, sort of like with the figure ground organization, like stuff like this, if you're more inclined to see the chalice, or if you're more inclined to see the faces, it may be due to past experience, it may be due to the context, I don't know, maybe you're thirsty or something like that. That sort of idea. Okay, so we also have monocular depth cues and binocular depth cues. So monocular is you can pick up these cues using one eye. So with your monocular depth cues, so with accommodation is this idea of being able to see the picture and sort of figure out the depth of something based on what is in front of what. So this idea of accommodation, linear perspective, interposition, texture gradient, they all contribute to ultimately seeing depth. So in this picture, we see your, three cars, all your things like that. So if you think about your cars and what I was saying, kind of having things in front of each other, this idea of interposition, you can tell that this car is in front of this car because part of it is hidden behind the other. So you know that if this hand is in front of this hand, that's why you can't see part of this hand, is what I'm trying to get at. And you know that then, it's kind of impossible for this green car to be in front of this blue car because of the fact that part of this car is hidden by this one. That's that idea of those monocular depth cues. Relative size as well, kind of what I was saying with the cup. If something's smaller, this car looks really small compared to this car. You know that these cars, if they were placed next to each other, are probably the same size. So it's that sort of idea of using relative size, height in the visual field we'll get to in a little practice question. But this idea about things that are closer to the horizon look a little bit smaller, because if you think of something being closer to the horizon, it's drawn a little bit, or you perceive it to be a little bit further away. It's often, I don't want to give away the question that we're going to do, but it's that idea that if something is further from the horizon, like this is technically further from the horizon than this car, so it's that sort of implication, obviously based on size as well, that it's a little bit closer to you because the horizon should be very far. So that is that kind of idea there. In terms of your binocular depth cues, you have retinal disparity, which is basically when your two eyes don't match up, and that sort of tells you where something is. So if you've tried, you put your finger here, if you close your left eye and then your right eye, you can see that they move slightly. It's just your brain being able to pick up on that and figure out where something actually is based on the input of both eyes. Convergence is this idea of what we can see here. When something's closer to you, your eyes have to physically turn in a little bit more, and that's how your brain realizes what's close and what's not. Okay, so here is a question using some of the monocular depth cues that we discussed. So using only height in the visual field, describe how an artist would draw a second balloon of the same size to show that it is further away than the one in the picture above. So thinking about that, we'll look at the answer on the next page. Trees need to be added to the picture. How could an artist use texture gradient to show that one tree is closer than another? So thinking about texture gradient, maybe going back into this picture that we looked at before. So with texture gradient, again, they're drawing trees. You can kind of think about it maybe with the grass. So this idea that things that are closer to you, you'll be able to see the texture more clearly than something that is further away. So, I mean, you can't really see it in this picture that well, but if you're at the beach and you look down, you can see the sand and you can see individual grains of sand, right? Whereas if you look a little bit further in front of you, you can make out it's all yellow, but you can't make out individual grains of sand because it's further away. So it's that idea of texture gradient. Things that are closer to you, their texture is more visible, whereas when they're further away, everything just sort of blurs into one. Okay, so here's the answer to that question. So the second balloon should be lower in the sky. So it's this idea of height in the visual field. Show that it's further away than the one in the picture above. So this is the horizon. I don't know if this is meant to be like a mountain or something. So to show that it is further away, you would draw it closer to the horizon. Okay, that's a lovely hair balloon, but hopefully that sort of makes sense because the horizon is further away. Okay, blah, 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 blah. So you can say about them being drawn smaller as well, which we kind of talked about with this car and this car. It fits into this idea of relative size, but also height in the visual field because this is closer to the horizon, but it's obviously also smaller. So you can mention that, but it said using only height in the visual field. So if you were to write something about how the thing should be smaller, you're not using the principle of height in the visual field there. So trees need to be added. How could an artist use texture gradient to show that one tree is closer than another? So the closer tree should be more detailed than the tree further away in the picture. So hopefully that makes sense. And you can see the comments down the bottom. So this is from an old year 12 exam. Doesn't say the year, but it's probably from like the early 2000s. And so you can see that in the year 12 exams, the VCAR examiners give you sort of like feedback or some helpful points. So it can be really good to look at your, have a read of some older VCAR papers, and then you can have a look at what examiners are saying. This is probably really important for 3-4. So it's just a habit that you can start to build. Obviously in 1-2, your Saxon stuff are decided by your school. But yeah, it's a good habit to sort of get into because in 3-4, it's a very, very helpful thing. So the earlier you get onto it in 3-4, the better. And they also tell you what percentage of students got it right and wrong. So you can see that 80% got that right, which is pretty good. Okay, so some sort of visual illusions. So this is the illusion of sort of when your arrowheads are facing different ways. So A and B, the line is the exact same size, but it looks like B is a lot longer, and it's just based on the way the arrowheads are facing. So that's the idea of it being an illusion. So an illusion is, of course, like this sort of visual distortion, I suppose. So A and B are exactly the same size, but based on the arrowheads, it looks longer. Line B looks longer. So it's just that idea about how the brain can be tricked into perceiving things. And I think it's just because one is open as opposed to one being closed. So for that reason, the brain is ultimately tricked. So it's all about this idea of how other things can influence perception. Because like even I'm looking at it now, like A and B did not look the same size, but they are. Okay, so the Ames room, I'm sure you guys will be familiar with this one if you've been to, oh my gosh, I forget the name, that place in Phillip Island. Okay, but yeah, you guys know what I'm talking about. So the Ames room is this idea of when you put your eye in, being aware this is using monocular depth cues because you only have room for one eye. You don't have room for two. So that's why we can't really judge depth that well. So the person on the left looks a lot shorter than the person on the right, even though, they're probably the same size, or one, could be the opposite in real life. And it's because the room looks to be flat because you're using one eye, but it's actually, oh my gosh, shaped like a trapezium. So you can see that again, you think it's flat, you think that it's equal, but this is actually coming forward. So this person is closer to you than that person. And that idea that they're a little bit higher as well. So you can see that the wall of the room actually goes like, it's wide and then it goes short. So this person looks like their head is touching the roof, when in reality, the roof is just coming lower and they're actually being brought closer to you. So that's why they look so much larger than the other person. So it's that idea of a visual illusion. Okay, so this idea of agnosia. So this is a neurological disorder when you are basically unable to recognize familiar things. So it's due to a brain injury, and it's not due to an actual issue with your sensory organs. So, you don't have an issue with your eyes or your ears or anything like that. So you're able to see things perfectly fine. But in the context of visual agnosia, you basically just can't recognize familiar objects and sights, like even sometimes people, just due to that kind of brain damage there. Okay, so we looked at biological influences for vision. So for taste, it's kind of the same things. So physiological makeup, there is something you need to be aware of. They are called super tasters. So the idea is that they're born with a lot more taste buds than the average person. So their perception of taste is much more vivid. So they taste flavors a lot more strongly than a like normal person with a normal amount of taste buds would. Hence the term super tasters. So aging, so you lose taste buds as you age, and sort of genetic factors as well. You may just be more sensitive to certain tastes than others. Again, perceptual set. You can see that this is like very relevant with taste as well, because your environment really influences your taste, and so does your smell. Your smell obviously influences your taste a lot as well. But the context, you know, your emotional state. Are you mad? Are you sad? You know, are you hungry? Have you eaten this food before? That sort of thing. You can imagine how that influences the taste of something. You need to be aware of this thing called miraculin. So if you guys have heard of miracle berries, so they make everything taste sweet. So it's a little chemical basically, and it binds to the, like the front part of the tongue is what tastes sweet stuff. So it binds to taste receptors there quite strongly. And it just basically acts upon them and sort of like activates them a little bit more. So then when you eat something, those receptors are like pinging like crazy, and that's why everything tastes sweet, because they're those sweet receptors sort of towards the front of your tongue have just been really enhanced basically. And so that's why, you know, there's little miracle berries, so they can make yucky things taste sweet. Yeah, I'm sure you guys have had them before. Okay, and then synesthesia and spatial neglect. I think this is our last slide before the next block. So synesthesia, again, you might have seen people that have this like on the internet and stuff like that, but they essentially perceive one sense with another sense. So it is this actual like kind of diagnosable thing. And so they can often like taste words. I feel like sometimes I see videos when it's like they'll say a name and then they can get like repulsed by the name because it tastes really bad. So it's that idea of, or like when they see numbers, they see colors as well. So it's that idea of a sense, so, you know, such as like a word can be associated and be paired with a taste or a sight, stuff like that. A sound maybe as well. Spatial neglect is something different. So this is often due to brain damage as well. So you kind of can more commonly see it with a stroke, often due to the rear parietal lobe. And remember the parietal lobe is associated with your kind of proprioception and that sort of thing. And they basically ignore everything on the left side of their body. So their eyes aren't damaged, like they have vision of their left visual field, but their brain just can't interpret it. So when they're asked to draw, so they're shown a picture of a clock, and they draw it like this, like half, or they're shown a picture of a house and they draw only half of it because in their mind, they've drawn it completely. It's this idea of, again, very much in the name, spatial neglect. They just neglect this entire half side of their body, or of their world, basically.